Greetings everyone and welcome back. Here's something fun. The enlarged Minecraft sword was made from scratch using 3D printed parts and custom PCBs. The concept was to create a full-size Minecraft sword with RGB LEDs fitted in order to create a wall light with a Minecraft theme. This 3D printed light is powered by a straightforward ESP12F circuit coupled to a customized RGB LED PCB. Due to the length of this sword, we had to split the models into 5 parts, which we then put together using nuts and bolt to form the entire sword. We load the image of Minecraft sword into Fusion 360 and set its dimension to 550mm by 280mm. Next, we model the sword by tracing its outline and then we extruded the sword with thickness of 60mm. Later, we further divide each section into two parts, which are the lid and the lower base part, which will house the LED board. We designed parts such that we could mount two sections part together with M3 bolts and nut in order to join several parts together. The LED board inside the crossguard and blade portion of the sword illuminates the PLA printed top plate part. The circuit is housed in the grip portion of the model. After the model was ready, we exported each of the 5 lower and 5 lid components into STL files, and then we used marble PLA for the lower parts and transparent PLA for the lid. The main circuit board and the LED board were the two PCBs that we had to model in total for the PCB design. The LED board schematic shows 7 WS2812B LEDs linked in parallel, which are intended for lighting the sword's top lid. Two sides has been added to the schematic, the input side and the output side. The VCC and ground of both sides are connected in parallel. The only pin that are different are the D in pin and D out pins, which each connected to different Con2 pad. The second board was the ESP12F board. As the name suggests, the ESP12F module used in board like the Node MCU or the ESP8266 products. In the schematic, we have added an additional AMS11173 3V version, which stepped down the voltage coming from the input side to stable 3V for ESP12F to function. After completing the PCB design, we exported the Gerber data and sent it to PCB for samples. Two orders were placed, one for the main circuit and one for the LED board. We placed an order for white silkscreen LED board and a blue silkscreen circuit board. After placing the order, I received the PCBs within a week, and the PCB quality was pretty great. The cell screen that I use is completely random and asymmetrical, so it's pretty hard to make, but they did an awesome job of making the PCB with no error whatsoever. You guys can check them out if you need great PCB service at an affordable rate and low price. For the whole assembly process of the PCB, check out this project page for a brief build guide and other important file. The link is in video description. Here's the code used in this build. The usual FTDI board method, which required connecting a flashing button between GPIO 0 and ground port, is being used to program the ESP12F module. During uploading the ESP12F, enter programming mode by long pressing the flash button first, followed by the reset button. You can check out the article I wrote about programming the ESP12F with an FTDI board. The link is in video description. The sword's blade part is assembled first by applying super glue on one side of it. Next, in order to maintain a firm grasp between two components, we first attach second part to the first one by using paper clips to join two parts together. After letting the super glue cure for half an hour, we fasten 4 M3 nuts and bolt to the holes on the each component. This keeps the two pieces attached together. Following that, the cross guard assembly and the handle part are then attached to one another using super glue. Paper clips are then added to firmly hold these two pieces together, and 4 M3 nuts and bolts are then used to fasten both assemblies. Using the same procedure, we were able to finally link sword blade assembly to the cross guard handle assembly. This is the end result of my little build. A functioning, illuminated, life-size Minecraft sword that I built from scratch using 3D printed parts and custom PCB. We are using a barrel DC jack to the USB port cable that is connected to a 5V 2A power source to power the system. By using two nails, we were able to mount this setup on a wall, thanks to the keyholes made during the model design process. The best thing about this project was how the parts were 3D printed on a small 3D printer and divided into smaller printable bits, so anyone with a small printer could easily build it. Overall, this project is completed and need no further revisions. Special thanks to PCBWay for supporting this project. Visit them out to get variety of services, including CNC services and PCB assembly or PCB making services. Peace out, and I'll be back with a new project pretty soon.